In this demo, we will show that we can go from empty hardware to a fully deployed mobile private network in less than 10 minutes. The solution has been built to orchestrate from 1 up to hundreds of MPN deployments. The audience for this solution is enterprises, managed service providers, and communication providers. The solution is entirely multi-vendor. It supports multiple core, switch, and hypervisors, and it can be deployed in cloud as well. It's multi-domain, so it orchestrates the virtualization, the transport, the 5G core, and optionally, it can also orchestrate firewalls, RAN, and other services. This solution and this demo at the moment uses the Athonet 5G core and Juniper Layer 3 switches on top of VMware ESXi. There are also extra services on the roadmap like push-to-talk, IMS, and others. The lab setup for this demo consists of 2 empty servers, 2 Juniper Layer 3 switches, all orchestrated by the Inmanta service orchestrator. And this is where the demo starts. Here we have the Inmanta service orchestrator dashboard, and we're in the service catalog. There are 2 services here. One, the MPN deployment that explicitly deploys to the servers and the switches. And then on top of this MPN deployment, we can add additional data networks. So let's start by deploying one MPN. The only parameterization that we have in this demo is the management prefix that will be used for each and every different MPN deployment that link back to your data center, so it needs to be unique, and then the PLMN ID. We can further parameterize and customize the solution so that you can control the parameters and the services that you want to be available in this MPN. When I click confirm, we're sending this request to the orchestrator, and the orchestrator is an intent-based orchestrator. So it does not have a workflow built in to deploy this, only describes the intent. We are now validating this desired state, and once we reach the creating state, we will start decomposing this into lower-level intent that we can manage in the network. This intent will consist of configuration on the switches, configuration on the Athonet core, so the switches through netconf, and then vCenter resources, the complete virtual switches, port groups, network interfaces. And then once this is the virtual machines are up and running, we can also start orchestrating the configuration inside the Athonet core. So let's switch to one of the ESXi hosts. And you see here that we are gradually adding more configuration. So we start with the virtual switches, port groups, and now we are deploying the virtual machine. And in a moment, we will power on this virtual machine. So this device is now booting. Once it is booted, the orchestrator will wait until the API is fully functional. And when it's functional, we will continue with the orchestration of the configuration inside the Athonet core. That's what is happening now. We send the request to the orchestrator through simple forms, which are actually just input fields on top of the API. In one of the next releases of the Inmanta Mobile Private Network Orchestrator, we will include a Smart Service Composer. And this will allow you to compose the services just by drawing blocks and the relations between these blocks, and then deploy this into the network. While we are deploying this is the final deployment once the orchestration is ready. We have 2 sites. Each has a Juniper switch and a server, and on this server we will deploy the virtual switching combined with an Athonet control plane virtual machine and an Athonet user plane virtual machine. This is one of the control plane virtual machines. There is still a user plane listed here. We do not have any licenses yet. This is what the orchestrator is now taking care of. As you see now, we already removed the UPF, and in a moment it will also have all of the licenses and the basic configuration to start deploying mobile private networks. Let's also switch to the network. Here you will see that we created multiple VRFs. We have a management VRF that connects all of the components together. And then we have a VRF for all of the signaling, and one that will allow us to connect the RAN. This is the control plane virtual machine. It has its licenses. This is one of the user plane virtual machines. This has only the user plane and it has a valid license. So the next step is to actually start deploying a data network. What we will do is reconfigure the SMF and the UPF to have a data network. We will create dedicated VRFs on the UPFs and on the layer 3 switches and set up all the BGP peerings to make sure that there is external connectivity possible. So once this is deployed, this is what we will have. On each side, there is the Athonet UPF VRF, layer 3 switch VRF. It's this VRF that creates the connectivity to the enterprise. The parameters for a data network are the name of the data network, the UE pool to use, the DNS servers for the UEs, the slice service type, slice distinguisher, and then a reference to the MPN on which we want to deploy this new data network. We will again receive the intent, validate the intent, and then determine which changes we need to make in the network to make sure that the desired state matches the current state again. This is what is happening now. We're reconfiguring the switches. We configured the additional VLAN on ESXi, and we push the config into the Athonet core. If we now go to the SMF config, you will see that there is a data network, and this data network links to the two different UPFs. The network has also been deployed, and that means that we now have an additional VRF, DN1. And you see that over BGP from the core, we get the UE pool. We split the UE pool into two equal sized subnets, one for each UPF. This is the switch of side 1, and it gets the pool from the first UPF directly advertised over BGP. The other one comes from the second UPF over the second layer 3 switch, which you can see here with the extra AS on the path of the routing entry. So now that it has been deployed, we can start attaching a RAN simulator to validate that this deployment actually works. We are using the UE RAN simulator. It allows you to simulate the G node B and attach UEs to this G node B. So it was able to successfully connect to the AMF. And then if we go to the control plane virtual machine, in the dashboard, you will see that there is now one active radio. Next, attach UE to this. It attaches successfully to the G node B and then also is able to set up a session to the mobile core, and it has gotten this IP address. If we go to the UPF, we will also see that there's now one active session and one IP address handed out, and we can send a ping over this tunnel towards the internet. The Inmanta orchestrator is also intent-based, and intent-based means that we will always be able to figure out a new workflow to go from what is currently in your network to what you want to be in the network. We're going to demonstrate this by actually deleting a BGP session from one of the switches and to show that we then are able to recover from this. So I'm going to let the ping run here. And then I'm going to remove a BGP session from the data network VRF. So we have the following configuration. And so when I delete the BGP session, we will see that we're no longer able to reach the internet over this session. If we now go to the orchestrator, we can always ask the orchestrator to now immediately verify whether the desired state is still correct in the network, or we can trigger. This happens at regular intervals. In this case, we are triggering this to speed up this process. It is here checking the netconf configuration of each of the switches. When this is done, we should any moment now see that the connectivity is back. And here we have connectivity again. This concludes the Inmanta mobile private network orchestration demo.